All right, good afternoon. How's everyone doing? Good. My name is Luke Hoban. I am today going to be talking about JavaScript, the language. To give you some background, I've kind of been working at Microsoft for a while on various programming language technologies. I worked on C# for a while, and then I worked on a language called F#. And while I was working on those languages, I talked to a lot of developers. Talked to a lot of developers who were working with JavaScript. And one of the things I noticed was that folks working with JavaScript tended to not treat it like they treat any other programming language. They treated it more like this kind of weird phenomenon that they had to deal with that had kind of unpredictable behavior and that wasn't really sort of as flexible and capable as they wanted it to be. And one of the things I noticed was that really, that isn't true. Fundamentally, JavaScript has a very simple, expressive core. It is just a very reasonable programming language, like every other one that we work with. But it does have some particular qualities that are unique, or at least unique amongst languages that are as widely used as JavaScript is, to JavaScript itself. And so in this talk, I really wanted to kind of go into a little bit about JavaScript and some of these simple core concepts that I think are really important to understanding JavaScript as the programming language that it is. So to begin with just a little bit of kind of historical context, as we always need when we talk about things like programming languages that have been around for the 15 years or so that JavaScript has. JavaScript sort of began in 1995, and I went around looking on the web for examples of JavaScript code from kind of back in those early times, and I found this one which I particularly liked. Wouldn't it be really cool to put an alert box on your web page? That's really adding value to the quality of your web experience. But this was the kind of thing that JavaScript was initially used for, was just very, very simple scripts on my pages, even so simple as just a single function call in a on-click handler. But JavaScript, it turned out, enabled a lot more than this. And so it started being used for increasingly more sophisticated things. And even as early as 97, I found this screenshot of Outlook Web Access. And this was a fairly rich application built using JavaScript and using the web technologies of that time. But this was a very sophisticated web application that kind of had a lot of the look and feel of desktop applications, and had a lot of client-side logic that was written in JavaScript and that was executed as part of this app. More recently, I found this quote out on the web that, fast forward 13 years or so, and Gmail, a kind of similar kind of application, is comprised of between 500,000 and 1 million lines of JavaScript code. When you start talking about projects that are at the scale of 500,000 lines to 1 million lines of code, you're talking about really large software investments. And the kind of way that you have to treat your programming language when you're working in a million-line code base is very different than when you are writing the alert script. And so as we see increasing numbers of these sort of larger applications built on top of this JavaScript and the whole web stack, it's increasingly important that we treat each of the components of it as really first-class things and try to understand what's going on behind the scenes. Of course, one of the things that's helped fuel and that's helping to continue fuel the growth in the sort of size of large web applications and websites is increasing performance of JavaScript. And so over that same kind of time frame here between 2001 and 2011, you see, and this is sort of just showing one particular data point using SunSpider data, and it's just showing Internet Explorer performance over that time frame. And you notice that that's not far from being 100x speed improvement on SunSpider over that time frame. So enormous amounts of performance that we're gaining over these last 10 years. This is enabling us to build much larger, much more interesting applications with JavaScript. And so again, over that same kind of time period, as we've seen the web evolving in a big way, the ECMAScript standard, which is the sort of specification, the standard that all of the JavaScript implementations sort of aim to adhere to, that standard has evolved as well over that time period. And the ECMAScript standard began in 1997, and iterated quickly in the first few years. And then there was an effort to do an ECMAScript 4 for a few years, and that effort was ultimately abandoned because it became a fairly large addition of new features to JavaScript, which was deemed to sort of have gone a bit too far on adding to the language. And so instead, in 2009, a more constrained set of features was added to something called ECMAScript 5. And so one of the interesting things to note is that the language itself, from the perspective of the standard at least, didn't actually evolve at all for about 10 years. So we had 10 years where the ECMAScript standard was effectively fixed at ECMAScript 3. And so with this ECMAScript 5 came a set of new features. And so the modern round of browsers, IE9 and the browsers from all the other vendors, are now implementing the features of ECMAScript 5. And so one of the things I'm going to talk a little bit about today, I'm not going into full depth on, but I'll talk a little bit about, is the features of ECMAScript 5 and how they relate to these core concepts of the JavaScript language. And I have a little key here. I'm going to have these little green boxes around things which are specific to ES5 so that you're aware when a feature I'm talking about is something which you'll need one of these newer browsers to leverage. And of course, the work on this standard is now, as we've obviously seen a growth in many of the web standards recently, work on the ECMAScript standard is continuing. And so we're working towards potentially another round of updates to the ECMAScript standard in the 2013 timeframe. But for today, at least, what I want to really talk about is, like I said, getting a deeper understanding of some of the fundamental core principles of JavaScript. And so we're going to talk about those core principles, some of the usage patterns for those core principles, touch a little bit about on some of the things that are new in ES5. But I should warn that I can't really give a comprehensive overview of the entire JavaScript language in the 55 minutes or so that I have left. So there's going to be a lot of stuff I'm going to leave out. I'm really going to focus on what I sort of perceive as the places where there's really interesting depth to the language. And if you understand that, all the rest of it is fairly easy to go and read about and learn online. So, okay. When I talk about JavaScript, I sort of see it being built out of a few key concepts. It has C-style syntax, obviously. That has a big impact on the feel of the language. It has dynamic typing, so that means we don't have a whole bunch of type annotations all over the place. We're not being statically typed. There is no compile time in this language. But then the really interesting pieces are these last three. So it has a built-in notion of objects, which is very simple but very powerful and flexible. And the most significant thing is it has a first-class notion of functions. And so I'll go into a lot of depth on these particular features. The thing that ties these together is a notion of prototypal inheritance, which really is the sort of glue that hooks together a lot of the core ideas in JavaScript. So I'm going to spend most of my time on those last three, but I just wanted to do one slide each on the first two just to give an overview. So I mentioned JavaScript has C-style syntax, so I tried to put all of the JavaScript syntax on one slide, and I think I almost accomplished it. This is effectively all the different syntactic forms that are in JavaScript. And so you can actually tell there's not much of it. It's not a big language. If you compare this to the equivalent slide for your favorite other language like C# or Java or Python, there's actually not that much syntax to JavaScript. The things that might be sort of unique to JavaScript relative to other C-style languages, we have literals for objects, for arrays, and for functions. We have automatic semicolon insertion, which just means we're really forgiving about where you put your semicolons. We have regular expressions as an expression form as well. We don't have to put those in strings. And as well as all the standard sort of for loops and while loops and things, we also have a special for-in construct, which lets us enumerate the keys of an object. But other than that, everything else here is just the same kinds of things that developers who've used any of the other C-style languages are going to be intimately familiar with. So JavaScript is often talked about as being an untyped language, which I think is sort of not really true. JavaScript is a very dynamically typed language, but with a very well-defined type system in its dynamic type system. And that type system is made up of a few kind of primitive values, numbers, bools, and strings. Numbers, obviously, are just floating point numbers, and so we just use floating point numbers to represent everything, integers, decimals, anything like that. And strings, we can use either single quotes or double quotes, which allows us a bit of flexibility with those strings. The one interesting part of JavaScript in terms of the basic type system is this undefined and null. And so there's two kind of notions, two of these types which have a single value. And undefined is normally used when we want to really say something is not there. So when we look up a property, it's not there, we say it's undefined. If something is there but has an uninitialized value, we'll use the value null. And so that's sort of the rationale for the two different values. But other than those 5 things, everything else in JavaScript is just objects. And this is a really powerful thing in JavaScript, that we don't have a whole lot more primitive types, that everything else is just built out of objects. But inside objects, there are sort of 3 subclasses of objects. And I'll talk a little bit later about some of the ways that these get differentiated. But there's effectively objects which are defined by JavaScript code. So when I write an object literal, I get back an object. There's one kind of object that we can see. There's objects defined by the host. And so Internet Explorer defines a number of objects, like the document object. And these can sometimes behave slightly differently than the JavaScript objects. And that's an important thing to be aware of. And then built-in objects are kind of similar to host objects, but they're actually ones defined as part of the language. And so they tend to be ones which are kind of hooked into aspects of the language directly. And they often have very special behavior tied to how they fit into the rest of the language. But I promised I was going to spend most of our time on objects, functions, and prototypes. And so let me jump in directly to talking about the concept of objects. So objects are just bags of a bunch of properties. So just some really simple stuff. We have object literals, which create a new object, and then we can both create and modify properties using the assignment syntax. We can also just define objects giving a set of pre-initialized values in there. So this object O2 has a property x to begin with, whose value is 3. And we can put any values we want in the properties of an object. So we can put other objects, we can put functions, we can put anything we want into these properties. After we've created an object, there's obviously 2 ways of accessing the data in that object. So we can access the properties either using the dot, which lets us use an identifier to look up a property in the property bag, or we can use the indexing notation with the square brackets to look it up using a string. And these are equivalent. You can think of the dot as just being a shorthand for the indexing notation. But the nice thing about the indexing notation is it lets you access the full set of string values, which you can use as keys. So you can use any string value you want as a key for a property. And so I can, for instance, use the string that has spaces and punctuation characters as a key. That's something I can't access using the dot notation. Okay. But the more interesting thing, if objects were just these property bags that could be string indexed and then have a bunch of values hanging off of them, that would be a useful data structure, but it wouldn't really be all that expressive. One of the things that makes objects much more expressive is the fact that they have this notion of prototypes. So you may wonder, if I say something like this, if I say var o1 is a new object literal, and then I try to get the value of property off of that and call it, it succeeds and gives me back some string here. So the question is, where does that value of property come from? And the answer is it comes from the prototype object. And so whenever we try to look up a property on an object, if we can't find it there, we move to its prototype. And so every object sort of has a link to some other object, or potentially null, that is going to be the next object to look at to try to find a property if someone tries to look it up. And so in this case, I'm going to use a few of these diagrams that just sort of show the linking between objects. And so here we have the empty object with no properties. And its prototype is this thing called object.prototype. And object.prototype has a few useful properties on it that we can use on any object effectively, any object which has object.prototype in its prototype chain. And so this is where value of comes from. It's one of the properties on object.prototype. So as I mentioned, the lookup rules for dot and for indexing are intimately tied into this notion of the prototype. And so that's what makes prototypes really powerful, is that the really fundamental way of doing lookup uses this chain to go and resolve those lookups. So I can, if I want, define a new object which has its own value of. And so in this case, I define an object O2, which has a value of property, which is its own function that just returns 10. And now if I do that lookup of value of and call it, I get back a different result. And that didn't actually change the prototype chain or do any sort of removing something from, removing a property from somewhere else. All it does is hide the property that's higher up in my prototype chain. So when I do that lookup and I go walking up the chain, I find it earlier, and that's the one that gets returned. And so I can do things like overriding in JavaScript just by hiding things that are in my prototype chain. So this notion of prototypes, we saw that if I just write the empty object literal, we get back an object which has a particular prototype. It has this object.prototype in its prototype chain. But if we want to create more we can create any general purpose chain of prototypes that we want. This was technically possible even before ES5, not just technically, it was a lot of people were doing it all the time before ES5. But there wasn't a built-in function that did it automatically, that just basically, if you told it, I want this object to be the prototype of some new object I'm creating, there wasn't a direct function in JavaScript to do that. And so in ECMAScript 5, a function called object.create was introduced. So this is available in IE9 and IE10. And object.create, I can just give it some object, and it will create a new object which has that as its prototype. And so you see in the diagram here, point3D is just a new object which has point2D as its prototype object. And so now if I try to go to point3D and look up x, I find that in the point2D instance. So one of the really important things is that I can share. So if I have another object that I come along and create this location, which has point2D as its prototype, and then I set a name property on that location object, now I have two objects which share the same prototype. And this is where prototypes gain all their benefit, is that we can actually share things between lots of different instances and just have one copy of that data in a particular prototype. And the really important thing to notice here is that it's objects inheriting from other objects here. It's not some notion of like types inheriting from types like you may be used to in sort of class-based systems. Here we really are talking about just an object who inherits from another object. Okay, so we'll come back to prototypes in a second, but I just want to talk about a few other interesting aspects of objects. So one is that we saw the first example of these data properties. So I can have a bank account which just has a property on it called balance, who has a value 1257. But one of the things that ECMAScript 5 introduced was the ability to have another kind of property as well. And that's something called an accessor property. In accessor properties, you provide a function to be called when someone tries to get that property, and a function to be called when someone tries to set that property. But the syntax that they use to access the property from outside looks identical. And so it allows you to basically intercept calls and into the getters and setters. And so with normal properties, we can't do anything when the property gets set, or we can't do anything when the property is retrieved either. With accessor properties, we have the ability to sort of get in the middle of those operations and do more interesting things. And so in this simple example, our get is going to always return 1257, and our set is going to do nothing. Now, one of the things, you notice that kind of takes the notion of a property and sort of expands it a little bit. So we had this notion that objects are just bags that take string keys and return and have properties that return values. With accessor properties, we're actually augmenting that a little bit and saying that those properties can actually be either data properties or accessor properties. But it actually goes a bit further than that. Each of those links to a property can have additional metadata associated with them that sort of configures them with certain information. So for a data property, for instance, whose value is 47, I can mark it as being either writable or non-writable, which indicates whether an attempt to come and change the value later on will succeed or not. I can also mark it as being enumerable or non-enumerable, which is just an indication of whether doing a for in over the object or some of the other operations that look for enumerable properties, whether that will include this property in the properties that it enumerates. And finally, there's a configurable, which tells me whether or not I can come along later and change any of these other properties about the object. So if I make it non-configurable, I can't change any of these configurations. And of course, as well as having data properties, we can have accessor properties. And those are represented with these descriptors where instead of a value and a writable, we have a get and potentially a set function. And so to show off a little bit about that, I wanted to just quickly show an example of what those kind of things look like in some standard code. So let me just open up the F12 tools. And so I'm just going to write some simple code in here. And unfortunately, I can't bump up the font in here, so it's going to be a little bit small, but hopefully it's readable enough back there. Let me actually just move it so it's in the middle of the screen at least. So what I want to do is just write a simple variable. So I'm going to say var o equals, and I'm going to say hello colon 5. And I'm going to use one of the ECMAScript 5 functions called object.getOwnPropertyDescriptor. A very long name. And what that does is it lets us get that descriptor that we saw on the last slide for any given property of any given object. So we can actually look into objects and see how they're configured and how they're set up. And so if I do this and I run this code, we see that when I use an object literal to create something, it's automatically initialized with a value 5. It's configured to be writable, enumerable, and configurable. Now, there's other objects in the system. I mentioned that there's both ones defined by the user, and there's things defined other ways. So for instance, there is a now property on the date object in the built-in JavaScript libraries. And so if we run this code, we see that we get back a slightly different descriptor. So in this case, the value is a function, the function that is the now, that computes the now. But in this case, this built-in object is defined by default to be non-enumerable. And so we can see that's why when we enumerate over something like a date object, or even a lot of the built-ins are the same way, we won't see those properties when we enumerate them. And this is something you can do to your own objects. You can go and modify them to be non-enumerable if you want. And the last category was things from the host. So we want to see things like things from the DOM, for instance. So let me just go and look up the inner HTML node. And we look at properties on the DOM, we see that they're actually even slightly different. The properties on the DOM are actually taking advantage of accessor properties. And so here we see there's a get and a set for inner HTML. And so this allows us to do more interesting things when the get and set operations happen. And you notice that they're also initially enumerable and configurable. So since this property is configurable, why don't we go ahead and try to actually change it and modify it? And so what I'm going to do is I'm going to write a piece of code which sort of does some interception. So every time someone tries to write to inner HTML, we're going to intercept it and log that call out. And so let me just capture this, the original property descriptor as old. And I'll say var newDesc equals. And here I'm going to define a new setter. So when someone tries to set this property descriptor, I'm going to say HTML content here. What I want to do when they try to set the inner HTML is I'm going to log out to the console. Inner HTML of this was changed to, and I want to change it to HTML content. So I will just log out to my console every time we try to change the inner HTML. Now, I can't just log it. I need to actually go back and make sure that the call to the original HTML set is done. So I'm going to take that old property descriptor, get its set property, which is here, and I'm going to call it. And I'll come back later when I'm talking about functions to talk more about this. But I'm going to call that, passing it this and HTML content. OK, and so now I'm going to use another one of the ES5 things called define property. So we have object.getOwnPropertyDescriptor, and the other side of that is I can do object.defineProperty to actually change the inner HTML to this new descriptor. So if I do this, oops. OK, so if I do this, I've now changed this particular property descriptor. And so if I rerun this line of code here, well, I won't do it right now because I want to quickly show off what this looks like. So let me put these two windows side by side. There we go. So we got one logging already. This web page was updating to show that the moments ago changed. But there's actually a few other dynamic elements on this page. So if I hover over these, you'll see it changes that inner HTML. So you're able to easily introduce some sort of interception of the inner HTML using property descriptors to kind of control and reconfigure some of these DOM properties. So this sort of thing is useful, and these properties, these object manipulation things like object.getOwnProperty descriptor and object.defineProperty are useful ways to play around with and explore objects. Okay. So just summarizing some of the things about objects. So objects are these string-keyed property bags, which is a very flexible core data structure for a language. You can build a lot of other interesting data structures on top of this. The real thing that makes them unique is the use of prototypes as a way of resolving lookup. And this allows you to do interesting things with sharing and to create inheritance relationships. And finally, properties actually have this very rich, rich context behind the scenes with all this configuration data and the ability now to have access your properties. Okay, so with that, I want to talk about functions. And functions, I think, are really the most important part of the JavaScript programming language and the cornerstone for so many of the interesting things that JavaScript can do. So just a really quick summary of the things that I'm sure everyone knows. We can define functions just by saying, function as a function statement like this. And we can also define functions using a function literal, this function expression, and then we can store that in a variable. And the two forms here are actually convenient because they show off the two sort of ways you can think about functions. You can think about functions like procedures in the way that you would think about them in sort of in the standard C-style language. But we can also think about them as just values, as objects, which we can pass around, we can store into variables, we can do anything we want with. And so this is the two syntaxes sort of show both of those usage forms for functions. We can, of course, intermix. So even if we define something as a sort of using the declarative form, we can then go and grab that as a first-class value and pass it to someone or store it in another variable somewhere. And of course, we can pass those into other functions. So we can have a function called wrap, which takes another function as an input and just goes ahead and calls it. And so functions really are fully first-class in the language. And this is really an important aspect of many different things. Now, as well as being first-class values that we can pass around, they happen to also be first-class objects. And so we talked about objects a lot. So if I define this sum function that takes an x and a y and returns the sum, what I actually get is an object, just like I would have if I wrote an object literal. The one difference is that this object doesn't inherit directly from doesn't inherit directly from object.prototype. It inherits from function.prototype, which itself inherits from object.prototype. And so that means we get a few extra things we can do with this particular object. So what we get back from creating this literal, this function literal here, is a few things. We get an object. It inherits from function.prototype. It has a length property. So any object we can come up to, we can ask, function that we come up to, we can ask it what its length is, and it'll tell us how many formal parameters it takes. And it has a prototype property. And I'll get back to how this prototype property fits in just a second. But the key is here that these functions really are just objects, and they fit into this whole chain of prototypes in exactly the same way as object literals, but they fit in with the function.prototype there. So one of the unique things about functions is they have a special treatment for this. So when I have a object literal like this obj here, it can have a property which is a function. And when I call that, you'll see that the calling syntax there, obj.sum of 3, 4, looks an awful lot like just a regular method call from a C-style language. And so what's actually going on here, of course, is that we're looking up a property, and that's returning back a function, and then we're going to call that function. And so it's actually not really, there's no special concept of members. There's just the concept of a property which happens to be of a function type. Now, that notion is changed just a little bit by the fact that there's this in the language. So if I have object 2 here, which has a sum function, when I come and call this sum function, as well as just looking up the property and calling it, what also happens is we set the this value for when that function gets executed to be the object that's on the left-hand side of the dot. And so we actually pass that object into the function as the this. And that allows us to write code that is much more in the sort of standard sense of what members are like, to have a this parameter and associate members with the object that they're called on. And this kind of thing works very nicely. However, there's one sort of pretty simple gotcha, which is if I do kind of break down that operation of getting the property and then calling it into two separate operations, like here. So if I say f is obj2.sum, and then I call f, now when I call it, this parameter is not bound. JavaScript doesn't remember the initial object that this function was retrieved off of. It just passes around the resulting function. And so that means that you have to be careful if you're getting a function from someone that if they used this inside that function, that when you call it sort of by itself, it's just going to be called with this being undefined, or sorry, this being the global object, which is going to cause offset to be undefined. Now, there's a couple of techniques you can use to work with this. I mentioned on the previous slide that one of the functions you get from function.prototype is call. And so you can just say f.call, and you can pass in explicitly what you want this to be. And I used that in the previous example as well to show off what it would take to just pass back in this parameter that you got from your caller. And so here we can reconstruct that call even if we don't have the original syntax source code for that, the way that we retrieved the sum function. Okay, so as well as special behavior for this, one of the really sort of unique to JavaScript aspects is that although we have prototypal inheritance, we also have a notion of new. And new is sort of in the language to allow us to have a notion that kind of feels a bit like halfway between this prototypal inheritance and kind of class-based systems. And so new, if you look at the syntax here, looks very natural. It looks just like new in many of the languages, many of the other languages you may work with. And so I can just say, once I've defined a function called person, I can say new person and pass in some parameters, and I get back a new object. But it's interesting to look at, well, so what really is happening when I do new? How is that working? How is that function involved in that process? And so what new does is it creates a fresh object, and that fresh object has its prototype set to person's prototype. So whatever function it's being used with, we grab that function's prototype property, and we use that as the prototype object for the new object we get. Then we call the function, we call the person function itself, passing in that object, and use that to initialize the object. And so in this case, you see that the person function actually sets up some of the state on that instance by saying this.firstname equals and this.lastname equals. And so new is actually sort of this aggregate of these three operations, which are really more primitive. And new itself is not really itself kind of a core primitive thing. Now, I mentioned that we use the function's prototype as the prototype for the new object. And the reason why that's important is it allows us then to connect new functions that are going to apply to every instance that gets created from this constructor person. So if I say person.prototype and I put a property getFullName onto person.prototype, I can now come up to any instance of that person constructor and call that function directly on it. And so this is really where we combine the use of prototypes with the use of new to create something that's a bit more like the kind of class-based models that many folks are familiar with. So let's just take a look at kind of how this stuff all adds up. So we've talked about objects and prototypes and things. How do these pieces all connect together? So we saw that Bob itself was just an instance of this person, and so it has person.prototype in its prototype chain. And so that means that we can say things like bob.firstname and bob.getFullName. But where is the person object itself in all of this? Actually, one key thing here, also the getFullName is actually, it has the same, we're sharing this one instance of getFullName. So we have, real equality. These things are actually exactly the same, whether we get them from Bob or get them from Anil. So the person property here, though, the person object here, comes into play as well. And so let's add that person object into the picture. So the person object is sort of connected to this because person.prototype is how we get to that object, which we can use as the prototype for all instances of person. That person object has, it's a function, so it has a length property. It has that prototype property that we saw. And there's also, interestingly, a link back the other direction. So any instance of a person can ask for its constructor. It'll get back a reference to the person function which created it. So we can use some functions like there's an instance of function built into JavaScript, which allows us to ask whether Bob is an instance of person, and that means does Bob have person.prototype anywhere in its prototype chain. This also means that we can do things like adding a function into all of the prototypes. But more interestingly, we can use that constructor link to do things like this, which is probably sort of an anti-pattern, but is something that is interesting just to be aware of how the links work. So if we have an instance of this person class, we can come up to that instance, ask for its constructor, and then use that to construct new instances of the person constructor function. And so all these links that connect all these objects are available on the objects. So I've still left out some pieces of this prototype chain, so let me just add some of those in. So we saw before that person.prototype itself was linked to object.prototype, and that person was a function, so it was linked to function.prototype, which was in turn linked to object.prototype. And so we see how just out of these very basic building blocks of objects, functions, and prototypes, we're able to create these interesting sort of networks of relationships and sharing between all the different parts of the system. And so in this case, for instance, you see that both the instance and the constructor function both get a value of function. And those are actually the same because no one else sort of hides them in the process. We go through these different paths and we find the ultimately same function to invoke in both of those cases. Now, I've shown a lot of these examples where I showed object.prototype or function.prototype in one of these pictures. But object itself isn't any different than person. It is itself just a constructor function. And so it itself has these constructor and prototype links to the object.prototype. And so you see that this graph gets really interesting. You can try kind of building these graphs for some of the other sort of objects that you work with in your class systems. But because of the ability to sort of arbitrarily build up prototype relationships, we can build really interesting sort of inheritance hierarchies between the objects in our JavaScript programs. Okay, so I wanted to just do another quick demo to show off a few of these concepts. So let me just close this down, open up another one. Okay, so first thing I wanted to do was, I mentioned that new was really not a primitive concept by itself, that was really kind of built up from some of these other aspects of how we can construct relationships between objects with prototypes. So let me just write out a simple function. Well, let me write out kind of some example data to work with. So if I have a function called point, and I say this.x equals x, this.y equals y, and now I say var a equals new point, 3, 4. So I can use that to just construct some objects. But if I want to, instead of using new, if I want to build a little function which does new myself, let's look at how we might be able to do that. So I can do something like write a function newer, and it's going to take as an input a function. So I can pass around functions as first-class values. So here we're going to try to pass in the person function and use that to create a new instance, just like we would with new. So what I can do, I can say var o to create the new object that I'm going to return. And what we said on the slides was that I needed to create a fresh object whose prototype is person.prototype. So in this case, I'll use that object.create from ES5, and I'll just pass it f.prototype. So now I have my object, and I need to go and call that constructor function on it to initialize it. And so naively, I could just do something like f.o, and then return o. This, of course, will only work if that constructor function doesn't take any arguments. And so what I really need to do is apply this and pass in the args. Let's also go and call that function, passing in the arguments that we provide. So let me now create a B using this. I'm going to say newer point, and I'm going to pass 3, 4 here. So now you see we get back an instance, B, which looks identical to the instance we got in the first example. This is just a quick example of how we can use some of these fundamental building blocks around prototypes and functions to go and build up some of these more sort of derived concepts like new and the sort of more class-based inheritance mechanisms. Okay, so one of the things I also wanted to show was just how some of these things, how these hierarchies of prototypes work in the DOM. And so just like we had before, let me just grab an element. So I'm going to say document.getElementById. And this particular New York Times page, if we go here, has its body is just called home. So I'm just going to grab that. And you see that when I get back this particular DOM element, it has a whole lot of properties. And I'll just add it to the watch quickly to just look at all this. So there's a ton of stuff on a body element. And so the question is, well, where does all that come from? And how much sharing is going on behind the scenes? And what are all the objects involved in how this thing gets looked up? So we can use some of these sort of object introspection features to go and understand more about that as well. So let me just say var o equals lm. And I'm going to print out some information about that. So I'm going to print out the o.constructor. So we'll print out what is the toString of the object that I get back as the constructor. And I'm going to print out object.getOwnPropertyNames of O. So object.getOwnPropertyNames is another one of these object functions that comes in ES5. This just gets only the property names of the properties on the object itself. It doesn't go looking up the prototype chain. So lets us see what is really on that particular object instance. So if I run this, I see that the home element that we started with is a HTML body element, and it only has actually 2 properties directly on that object itself. So all those other properties that we found are being shared higher up in the prototype chain. And so we can do things like come up here and say object.getPrototypeOf. This is another ES5 thing, which lets me go and find out what that inner link for the prototype is. And so I can do that to just move one step up the stack, and I'll run this again. And we see that now we've moved up to HTML body element. And it has a whole bunch more properties on it that we see here. And we can continue doing this, kind of going up the prototype chain. And we see we get HTML element. There's actually quite a few more layers of this sort of thing. And this whole hierarchy of objects means we get a lot of sharing. So the properties in the DOM that are shared between wide sets of different element types are shared at the appropriate level in that hierarchy. And that's all represented in this prototype chain. But to most JavaScript code, that's all effectively invisible because we have the sort of implicit walking of the prototype chain. But we can use things like this to go and explore how this is constructed behind the scenes. Now, this particular sort of realization of the DOM that we see here in IE is actually something that's been being standardized recently in the process of standardizing something called WebIDL, which is standardized how we sort of convert the way that the DOM is specified into a set of JavaScript objects. So some of the things I've been showing you here about how the DOM is represented using ECMAScript 5 notions are things that have come out of the WebIDL standardization efforts. Okay. So there's one last thing I want to talk about for functions, and that is the scoping behavior. So one of the other really key things about functions is that they introduce their own scope. In fact, they're the only construct in the language which introduces a new variable scope. And so if I have a var x equals 5, like here, if it's inside a function, that var x is different than any var x that was defined outside of the function. So those aren't going to conflict in any way. For every other construct in the language, like for loops and if statements, those var x's inside and outside are actually the same, and they're going to conflict. Those names are going to conflict with one another. So functions are a really key construct for introducing scoped bindings of data. And so this example, we have this var x. And if we introduce this here, it doesn't pollute the global environment because it's just within this function. And so it's really valuable to put code that you're writing inside, inside functions, so you're not having it be just executed directly in the top level. So this kind of notion can be used in other ways too. Actually, one thing I should mention quickly, here when I'm using this function, I'm using it in a kind of what looks a bit funky. It kind of looks like a symbol soup there at the bottom. I'm defining a function and then calling it immediately. And that's really just, I'm only using the fact that functions introduce their own scope. I'm not defining a function which I'm going to call later. I'm not storing this function away anywhere. I'm just using it as a way to mark off a piece of my code and say I want this to be its own sort of scope. And this is a technique that's used quite a bit in libraries and things, and should be used quite universally to make sure that the sort of scope of the variables you define is appropriate. Yeah, there's a question, yeah. Yeah, the last example I have on this slide will be very similar to that, and so I'll come back to that specific example in just a second, but I can definitely speak to that. So one of the other aspects is that although we have our own variable scope inside a function, we can still access things from outside the function. And in fact, we can access things outside the function. We get sort of a by reference handle to those, which means we can actually modify things outside our function. And so in this case, we have a var outer defined outside the function, and inside this function, we can change that. And this is a very useful notion. This is a notion that's referred to as closures. You may see in a number of texts and things. And it's a very flexible notion of being able to capture some state and then pass around sort of an encapsulated reference to that in a function object to other parts of your system. And so this general notion is used all over the place in JavaScript libraries and in a lot of JavaScript code. So the last example is we can actually sort of use this technique to kind of isolate ourselves from outside code. So in this case, we have an outer called hello, outer called outer, whose value is hello. And if we want to isolate ourselves from any changes to that variable over time that might happen, what we can do is we can define a function which takes that as a parameter, and then we can call it immediately with the current value of that. And that means that inside this function block, we've actually captured the value of that when the function was first executed. So that means that then if we do something like set interval, which is going to execute sort of periodically over time, every time it does this, printing this outer, it's always going to be hello, even though we went and changed it to goodbye later on. And so this is a useful technique for sort of isolating yourself from other aspects of what the code is doing. And so there was a question about, jQuery uses this kind of pattern in a few different ways. So one of the techniques they use in the implementation itself is they use this as a way of getting the window object and making sure that they're not sort of susceptible to anyone changing the window object in any way later on. They capture a reference to it using exactly this pattern right up front when jQuery is initialized. And all of the jQuery initialization is done within one of these function blocks. There's also the notion that they'll actually define inside jQuery, they'll define a thing called jQuery, but then they'll ultimately bind it into $ using the same kind of technique. And I think that's what the question there was. And so this technique of using these sort of function blocks as a way of kind of hiding away a lot of your implementation is a really powerful thing. So functions end up being the primary, in fact, effectively the only encapsulation mechanism, the way of hiding some of your implementation, hiding some of your state from other parts of the system. So you can sort of think of prototypes as the way of sharing, and functions as the way of kind of hiding and encapsulating, which are two of the key software engineering components that you need. So just summarizing there on functions. So a few of the important points. Functions are just objects. We can pass them around. They're first-class things. They have this function.prototype in their prototype chain. This is really a unique sort of thing with functions. So if we have this, its value inside a function is going to be dependent on the way in which it was called. That's very useful for kind of defining functions which are going to be used like members associated with a particular object. New is a way, sort of a derived form in the language that allows us to kind of build up these particular patterns where we have a constructor object, and then we define some sort of members using on the prototype that are shared. And finally, closures and this ability to define scopes is a really powerful way of doing sort of information hiding and isolation. So the one last thing I wanted to talk about here was sort of a new thing that was announced this morning. This morning in the keynote, Dean talked about IE10 Platform Preview 1 was released earlier today. One of the really exciting parts of that release was the inclusion of a new ES5 feature called strict mode. And strict mode is a feature that was standardized along with ES5, but has come online a bit later than most of the rest of the ES5 features. And it's a really useful feature that allows you to sort of explicitly opt in to using a more constrained subset of the JavaScript language. So the way you opt into this is by just putting as the first statement in a function body or at global scope, you just put as a first statement the string useStrict. And so if you have that string as the first statement in your code, then the JavaScript engines are going to now treat the body of that code and anything that it calls in a slightly different way. And most of those things that they're going to do slightly differently are about enforcing that you don't they're giving you quicker errors if you do things that are probably wrong, and restricting your access to certain things which leak and kind of can cause potentially you to leak more information than you'd want. One key thing about this way of opting in is that it's backwards compatible. So if I put this on a function, I haven't broken that code when I go and run it still in IE6 or IE7. And so this is really important. It means that this function is still going to continue to run. I'm just not going to get that checking on those older browsers. I'm not going to get the extra checking and extra validation. Now, there are some semantic differences, though, so you still have to test on both platforms and make sure that you're not taking advantage of any of the constructs that have some slight semantic differences. But as long as you are still testing, you can still start using this feature in any code that you have today. So some of a few examples of things that strict mode enforces. So one is that this is a big mistake that gets made all the time. You mistype the name of some identifier that you think was in scope, and suddenly you start adding properties to the global object instead of changing values in your own scope. And so if you do accidentally do that, if you say x equals 5 and there is no x, in strict mode this will actually be an error. So you'll actually get an error thrown at runtime as soon as this happens, and you'll find out about that in development. Things like arguments.caller and arguments.callee, which can expose a bit of information that about sort of how all the calls are arranged in the call stack. These are restricted. There's a set of these kind of features that are restricted in how you can use them. And lastly, we talked about some of these configuration properties, like things being writable and configurable. And so normally, if I have a non-writable property and I try to actually change its value, it'll just silently not happen. So it won't throw an error or anything like that. In non-strict code, the value won't change. In strict mode, that will actually instead throw an error. So we'll actually find out immediately that we were trying to modify something that we shouldn't have been able to modify. And so again, this is an example of just being a bit more upfront about giving you errors when you do things that probably aren't what you expected. And so let me quickly show a few of those in action. If you're at the keynote this morning, you probably saw a demo of this try strict new thing up on the IE test drive center. And so this is a little console where we can go and test out strict mode in the IE10 Platform Preview 1. And it comes with both the ability to type your own code in here, so we can just come in here and get some code where we could just type in the middle. But let me just quickly show you a few of the examples of the kind of things that strict mode changes behavior of. So one, there's a couple of changes to eval. So if we try to use, in this case, eval is being used as a name of a property, and this is actually an error. Eval is now not valid as an identifier name. But more interestingly, where's the one I want here? Here we go. So if I try to use eval and I pass it a string which says var x equals 5, that would typically in JavaScript, that would actually introduce a new variable x in the current scope. And so it would basically change the scope that this was executing in to have an x. And then this return x here would actually give us back that value 5. In strict mode, because that can be kind of dangerous, that can allow code that you eval to kind of modify your actual execution. In strict mode, this actually goes and makes sure that a new environment is created for that eval, and that eval isn't going to modify the current environment. So if I run this, you see I get back the value 10, but the code executes successfully. Some of those constraining things, I mentioned if I try to write to undeclared variables, I get an error. So here if I try to change A to B2, B to B3, we get back an error here in strict mode. And if I do things like assign to a non-writable property, so here I defined a property that was non-writable, and if I try to change that property, you'll see I get back an error here as well. So assignment to a read-only property. And so really, I was talking to someone after the demo this morning. They're like, I'm surprised they showed that demo in a keynote because it really is, it's not nearly as exciting as just pretty fish flying around. It's actually showing you less things that you can do. But it's actually really important to have those constraints and to find some of those errors earlier. And some of the things that strict mode helps you with are really things which are best practices anyway. And so strict mode just helps to make sure that you find out about violations of those earlier, and that it's done, you don't rely on some external tool. You're really just relying on the runtime itself. So it's a nice feature to have now in the IE10 platform preview. Okay, so just summarizing everything we talked about. JavaScript really is a programming language just like any other of the programming languages you may use. And really, it's useful to think about it in that way and think about trying to understand the core concepts that are building blocks for how JavaScript works. And if you understand those, and you understand some of these fundamental pieces of how objects and functions and prototypes all interact, it can give you a much deeper appreciation for frameworks and libraries and things that you work with in JavaScript. The IE9 and IE10 platform preview are out. It's definitely worth grabbing those. You can use the F12 tools to play around with using some of these new ES5 features to kind of introspect and play around with the objects in your systems. It's a really nice way to learn some of these concepts. And if you want a really deep dive into ES5 and all the new features that are there, Doug Crockford has a talk tomorrow that's specifically an hour of just ES5. He's going to basically cover the entire thing end to end. And so I definitely encourage you to go to that. And I'd encourage everyone to start looking at strict mode as something to, on your websites. Start looking at whether you can apply the strict mode thing. Use the IE10 platform preview build to test out how your site works under strict mode if you need to make any changes for your code to run correctly in strict mode. And so with that, I'll just say thank you and open it up to some questions. And note that we have some giveaways that are being done by the Internet Explorer team. And so if you're interested in kind of trying to do some puzzle solving around some HTML, CSS, JavaScript things, there's some interesting puzzles here. And I encourage you to go over to the booths to learn more about this and get the actual things. So with that, thanks a lot, and I'll open up to questions.
Notice you didn't point out what the difference between this and var, the variables inside of functions actually do.
So the question was, I didn't point out the difference between what this and var variables do.
This x and var.
Oh, I see. Yeah. So the question is, what's the difference inside the person function, for instance? What's the difference between saying, var x equals x and this.x equals x? And so this.x actually, changes the property x on whatever this happens to be. And in that constructor pattern, this will be the new object that I'm trying to initialize. If I said var x, I would just be creating a new binding inside the lifetime of that function call, but it wouldn't actually change any objects. It would just be a variable that was available. And so if you want to actually change an object, you need to use the sort of property assignment notation. So you have to say this.x or some other object.x. So those are really fundamentally different things. Var introduces a sort of local variable, and property assignment changes or creates a property on an object. Yeah, there's another question over there. Sure. Yeah, so the question was about why JavaScript has the triple equals instead of double equals. So it actually has both. No love lost on the double equals as well. The double equals in JavaScript, though, is kind of a loose equality. So it actually, JavaScript operators all do a lot of sort of implicit conversions of data. So they'll try to turn whatever their arguments are into the appropriate data so then they can do the operation. And so very few of the built-in operators in JavaScript ever fail. They just do the conversion they need to and then succeed doing whatever it means on the resulting object. And double equals is actually the same way. It actually converts both of its objects in certain ways and to try to compare them for equality. Now, normally when you want to compare two objects for equality, you really want to compare those two objects or those two values for equality. You don't want to convert them first. And so triple equals does the more strict equality of actually testing, doing no conversions, just testing those actual two arguments. So typically speaking, triple equals is what you want. But a lot of the time, double equals isn't a problem, but it will do some extra conversion. Yes, there's an object question over here. Sorry, yes. So how would you figure out your call stack, basically walk up and find out who? I believe that's not actually possible intentionally and not possible in strict mode. Ellen back there may be able to correct me if I'm wrong, but I believe, yes, that's not possible in strict mode. And I think being able to see your whole call stack is a security, is a very powerful thing, but it's a security sort of hole, right? It lets you see back to folks who called you and maybe mess with those functions somehow. And so not being able to get the call stack is actually something which is an important way to constrain what code can do. So that is a constraint. And there are some of the strict mode things which actually do let you do strictly less in terms of functionality, not just you have to do it in a different way, but there's strictly less you can do. And those typically are motivated by sort of security concerns, that we can use strict mode to enable more security mechanisms. Sorry, what was the application I was using in the demos? So that's actually the F12 tool. So if you go into Internet Explorer and you just hit F12, or go into the developer toolbar on the side, that's just the standard tools that are available to play around with JavaScript. And there's quite a lot of tools there. There's debugger, there's profilers, there's HTML inspectors, a lot of good stuff. Okay, apparently we're out of time. I can take questions over on the side for a little bit, but thanks again, everyone.